0. So if we use part A of the last proposition, you got something on both plus two different things, so those two different things must be equal. Cool? I know this is a little precise and boring. Let's be okay, so B is saying, so B is cool because I get to use contradiction. But this is saying if x and y are not 0, then x times y is not 0. So assume x times y is 0. Okay? So what do we know we can do because x and y are 0? So this is for contradiction. Sorry, I'm writing everything quickly.
They have inverses.
What's that?
They have inverses.
They have inverses. So this tells me that 0 is equal to, so 0, let's say, times, let me just write 1 over x times 1 over y. So this is multiplied by two different things. Does that make sense? Is equal to, oh, the other way, just to make it easier. 1 over y times 1 over x times xy. This is just 1 over y times y. I mean, there's no 1, but civic sense part. And this is just equal to 1. And that's a contradiction, because this over here is 0. The 0 times anything by this thing up is 0. Is that too fast? Guys? Yeah? Everyone's happy? Again, you know that 0 is, we're assuming xy equals 0. And for contradiction, we're assuming this. So there's a contradiction. So what I just realized is if I multiply by 1 over y times 1 over x on both sides, on one side I get 1, on the other side I get 0. And by the field axioms, that can't happen. Right? Okay, I'm assuming that's a yes. You guys should talk more. What's next? I'm only going to do a little more. The reason I'm doing this is there are problems like this on your homework and you're expected to do them at least to some degree justifying what you can. This is by, I think, the first proposition party, I don't know. Okay, so this next guy, I want to show that, so what I'm actually going to do to show here is, if you guys don't remember equality as transitivity, whereas in like if A is equal to B and B is equal to C, then A is equal to C, right? So I'm just going to show these two guys are equal to this. How do we show this is equal to this? Well, so what property does this have? This has that it cancels xy. So we're just going to add the first guy to xy. We're going to take xy plus, and I can already see you guys bored going up to it. So we're going to try to make sense of this, but we realize this is just equal to x plus negative x times y by the distributive law, and then we're going to get that this is 0 times y by, I don't know, this is probably a5, and then this is equal to 0 by part a. So minus x times y equals minus xy. And I'm sure you guys got to do the other one. Yeah, okay, we're going to start moving quicker. This last one, P has to be some cool trick. Oh, it probably does. Right, this is such a pain. Oh no, this is easy. So using part C, this times this by what we saw before is just minus this times this, which is just minus this times this. And from what we proved, I think it was in the previous proposition, this is just xy. Right? This is minus something. This is just xy. Great. So the reason, okay, again, so why was I doing this? Because this week only I expect at least showing all the steps. And the reason I wanted just to show you these basic ones is just because these are properties you expect, and these properties exist in every field. This exists on that field I showed you with 2 elements. This exists, in fact, if I gave you a field of 7 elements, that would work. This exists over Q, this exists over all these really weird fields that exist between Q and R. But these are properties that everybody has. So let's take a second. I just want to see if you guys can do it. But prove to me see if you guys can prove letter E. Feel free to work with the people around you and see if you guys can do letter E really quickly. Prove that minus x plus y is equal to minus x plus minus y. I'll write that nicely.
Huh?
Okay, it might be a good idea just because if you are working with the people around you, it might be a good idea to
I'm not sure what you mean.
Yeah, that was a king.
Negative x.
I mean, it was a king right
So we
there.
had x.
Ivan,
Yeah.
you explain the rest of part C.
What?
Will you explain the rest of part C? You only
The rest? Oh, I only did half of it.
Yeah.
Right, but now you do it for the other one, x times minus y. Do the same distribution, but for pulling x out. Oh, it's the exact same argument.
Okay.
Yeah, it's the exact same for the other one. Sorry, that's very rude and that's You guys are very quiet for people who are carefully discussing what I brought up. I don't really need a third one. You guys are very quiet when you work for the University of the West. Telepathy must have figured out since I was wonderful. So I'll be able to define an ordered set and we'll do ordered fields tomorrow. Wonderful. I basically plan the first half of my tomorrow's going to be a master of tomorrow's You're proving that I don't even want to use on the focus. That's extremely useful.
I'll just start off.
So,
How is this
any luck with this guy so far, or?
You let x be on -1 and then distribute it to there. You get -1 times y, -1 times z.
That's roughly what's going to happen. You have to reorder stuff, yeah.
I did because this
I'll get to it in a second. I'll let you guys talk for a minute more. And then I'm going to define an ordered set and give a couple of examples and we'll call it a day. And we'll talk about ordered fields tomorrow. Bound and these upper bounds. Yes, those are going to be so much fun. I'm excited. I get to teach you your first purely analytic proof technique tomorrow. So, hey guys.
Oh, okay. You're right.
Out of curiosity.
So they would have to be the same for z equals 0.
Out of curiosity, guys, what's the trick to getting it to work? Or anybody? Right, the point is if I want to show these are equal, I should show when I add this to x plus y, I get 0. Agreed? So then you just calculate, well, what's x plus y plus minus x plus minus y. And then you realize, oh wait, we have the commutative property, we can move these guys over. Right, by the commutative property, which is what, A2. And then this gives, so right now the proofs are really simple because I'm giving you crap like this. But this is 0 and this is 0. A5 maybe, which gives me that this is 0 by A4. Here you go. And it's very easy. But the reason is I'm just pointing out this is the kind of thought process you have. I mean, this is, again, easy stuff. I'm glad you guys are getting it. But the thing is, this is the kind of stuff you're going to have to be thinking later. This is the statement here, you have to dissect it for what it is mathematically. It's saying when I add this to x plus y, I get 0. That's what it means to be equivalent. It doesn't mean, like, it's not some set of equality of numbers, even though it's equivalent. And the other thing is, as far as we know, even though we all already know, this isn't the same as multiplying by -1. Yes, it's just notationally different. But it is the same as far as when we get to R. Cool. So let me give you one last definition, and then we're going to call it a day. And then you guys can prepare for, I guess, 8 more weeks of me, like, at least mentally or emotionally or whatever the case is. Oh, yeah, one other comment. Don't forget, 2 Mondays from now, there's no school, right? That's 4th of July weekend. In fact, it's 4th of July. First time I think 4th of July wasn't on a weekend since I've been teaching here. Great. So let's see, in ordered field. Sorry, not the one for order. I want to do ordered sets. Okay. So the last thing I'm going to do is only define. So this is going to be the section on ordered sets.